Hello, this is section 2.3, question number 25. Okay, the directions say evaluate the limit if possible. All right, so we are given the task to figure out the limit as t approaches 0 of 1 plus t underneath the root minus 1 minus t underneath the square root, all divided by t. Once again, if I applied the limit directly, I would have the square root of 1 plus 0 minus the square root of 1 plus 0, all divided by 0. And the temptation then is to say, well, that's 0 over 0, so 0 over 0 is undefined. And the problem is this is incorrect. This limit actually does exist. And as a hint, I can tell you again, that if you find yourself writing 0 over 0, so that means it's undefined, on a quiz or a test, I can guarantee you have gotten the question wrong. All right? This is not true. This limit, in fact, actually does have a value. Okay, so let's look at how to do that. Let me erase this part first. Whenever I see the situation where I have something like a root minus a root or a root plus a root, I'm going to use the technique of a conjugate. And in this case, I'm going to use the conjugate of the top. So the limit as t approaches 0. And then I have to multiply 1 plus t, take the square root, minus 1 minus t, take the square root. And that whole thing, I'm going to multiply both top and bottom by the conjugate. So 1 plus t, take the square root, plus 1 plus t, 1 minus t, take the square root. So I multiplied the conjugate on the top. Then I'm going to do exactly the same thing. When I multiply to the top, I have to multiply to the bottom. So t times the conjugate of the top, so 1 plus t, take the square root, plus 1 minus t, take the square root. So I multiplied the conjugate of the top to both top and bottom of my limit. Okay, so for the top, that simplifies nicely, and that's the purpose of our conjugate. And you can also see that if you're careful, this is the undone part of a difference of two squares. So I have a minus b times a plus b. Well, then that just becomes 1 plus t minus 1 minus t. That would be the difference of those two squares. And then I'm just going to recopy the bottom. T times 1 plus t, take the square root, plus 1 minus t, take the square root. Okay, when I simplify the top, I get the limit as t approaches 0 of, I'm going to have 1 minus 1 for 0, and t plus t for 2 t's. So 2 t's on the top, and in the bottom, I'm just going to recopy. So 1 plus t, take the square root, plus 1 minus t, take the square root. All right? So now I can just simplify by simplifying out those t's. So I get the limit as t approaches 0 of 2 divided by 1 plus t, take the square root, plus 1 minus t, take the square root. If I apply the limit to both top and bottom, I'm just going to get 2 on the top, and then I'm going to get 1 plus 0, take the square root, plus 1 minus 0, take the square root, and that simplifies to 2 over 2, which is equal to 1. So we see that the limit that we started with is not undefined. It's equal to 1. Okay, if you have any questions, please send me an email or stop by